Hello, everybody, and welcome back to another live stream. If you caught that, there was new countdown music there. Fun fact: that is actually AI generated music. I was so just for context, when I first started doing this live stream series, and I was looking for countdown music, I'm very mindful of correct rights usage, if you will, making sure that people are like I'm not using music unfairly or anything like that. So the original countdown music I got was from SoundCloud. I found like a guy out there who was like, "Hey, you pay X amount of money and you can have this 5 minute clip here for commercial use." But like I actually used Suno AI to generate that new music, and I read the terms and conditions with Suno, and as long as you have an active subscription while you create the song, then you can use that for commercial use. So a little bit of a fun fact there. So today's drink, by the way, is Rooster Booster from QT. So Bloomington just got a QT like a month or so ago, and I am a big fan of Rooster Booster, so that's exciting. But what I'm most excited about is the fact that we are finally going to wrap up this this series today. So if you recall, if you've been watching along so far, I started this streaming this particular project with the intention of doing it in one stream. And that was very naive of me. I really thought we were going to be able to get through. I knew it was like if it was going to be long, I knew it was going to be long, like a longer stream. But and then we came into part two, and then now we're here in part three, and we're definitely going to wrap things up today in part three. All right, so let's give a recap of what we've been doing and where to help us move into what we're going to be doing here today. So, as a reminder, we are working through Kaggle's playground competition for the month of July, and I'm not necessarily going to recap everything about Kaggle. You can go and watch the first stream about that. But basically, like this particular month's stream, playground competition is specifically situated around this classification data set, specifically trying to classify introverts from extroverts. So they gave us a bunch of data that has a number of features associated to it that would help us indicate whether somebody is an introvert or an extrovert. And then let me go ahead and share my screen and kind of talk through this. So this is the completed notebook, by the way. This is up on my GitHub, so if you want to go and review everything, and I got plenty of markdown notes and annotated comments throughout of what we did. This is, again, just kind of recapping what we did before. So in the first stream, we did exploratory data analysis. So we looked at our data, we did things like a meta-analysis, we did like a univariate and bivariate analysis, just looking at the variable by itself, and then also comparing the singular feature to the target feature. And then the essential goal here was to get a deep understanding of what the data that we're working with. And if you recall, most of these features that we are working with are very largely binary in the sense that, so like even with these range-based features where you had like this feature here called time spent alone, where all the records have a value between 0 and 11, if you look at how it's divides out with like introvert versus extrovert, you can see that we got a lot of extroverts on one end, a lot of introverts on the other. And then a common thing that we kept finding was this place in the middle that I'm calling the ambivert category. And this is like one of those ambiguous things where we're not necessarily sure if these people here are extroverts or introverts if we were just kind of looking at raw data and didn't have the label data. Now, the thing that we need to be mindful of is even though we are kind of looking how do we handle the ambiverts, we are not predicting on ambiverts. At the end of the day, we are trying to predict of extroverts versus introverts, and that's going to be exactly what Kaggle expects whenever we submit this notebook as part of our competition entry, which we'll be doing at the end of this stream. Okay, so that's a very high-level recap of the exploratory data analysis. And now let's move into our recapping our next part of the stream, or part two of the stream, that is, and that is around feature engineering. So now that after we did all of the the exploratory data analysis, then we moved into feature engineering. And so what we had to do were things like I was noting before, we were doing this range-based binning. And the reason that we were doing the range-based binning was specifically because, again, we found a lot of these various features where we do have the introverts, we have the extroverts, but then we have this little carve out in the middle that represents the ambiverts, if you will. And if you recall from the previous streams, we noted that this is going to be the most difficult part of the competition to handle. And I also, so again, to recap as well, I'm not trying to win this competition at all. And the reason for that is, again, I noted this in the first stream, but like the people who work on these sorts of things on Kaggle, some of them take it extremely seriously. Even though there's no prize money associated with the playground competitions, they still will put in many hours into these kinds of projects. So I just simply don't have the time to do that. So we're taking a little bit of a naive approach with how we did some of these things. So I don't expect to win by any means. But it's still I still approach this because this is a good way for me to keep my skills fresh, potentially learn new things, and then be able to share with you all here in these streams as well. So yeah, we did the feature engineering. We had to handle our nulls appropriately. So the way that we handled the nulls is basically we looked at because like if you are an introvert, for example, your introvert, like if a lot of the features that we were seeing, like these post frequencies or the time spent alone, they were highly what's the word? Highly correlated. I'm struggling to come up with a better word. And what I mean by that is basically like when we're trying to figure out the null values, the approach that I took was basically said, okay, let's look at every other feature that we have and see like what the leaning is on those. So if the leaning on some of the other ones is you see extrovert, ambivert, extrovert, then naturally speaking, the way to appropriately fill that null value is with an extrovert. Now, for the range-based features, like time spent alone here, for example, you might be wondering, well, how do we feel like, okay, let's say we determine somebody is an introvert, for example. How should we assign that null value? And what we chose to do, and we could have chosen a different path here, again, this was a little bit of a naive path, was we took the median value that we saw from here and then used that as the null entry. And we actually did a dynamic calculation of the medians. As you can see here, this code block right here is doing that. So scrolling on down here, we had to do one-hot encoding, and then we also had to do some engineering for logistic regression. Now I'm reading this here, and I'm recalling now that like I did this specifically for logistic regression because this was going to be the only model that we were testing what am I trying to say here? This was going to be the only model that I was testing that was going to be sensitive to this kind of stuff, but we will be testing an additional model algorithm today that will require this kind of scaling. So you'll see variable names here for me to differentiate as like _LR. The _LR stands for logistic regression. However, you'll see, I'll just say it's a support vector machine, SVM. Support vector machine is also going to be sensitive to these kinds of things, so we are going to be using that again here. And then finally, when we got into the end of the feature engineering, we hardened all of our code into these things for scikit-learn called pipelines. So you can see here we created this special class that we called feature engineering, importing the base estimator and transformer mixin components from the scikit-learn library. And the nice thing about this is then we can basically pop in all of our code here and be able to use it for like a pipeline, just like we do right here. Now, you might be wondering, what is the value of doing this? Because I actually did not explain this super well in the last stream. I was just actually watching the last stream right before this one. And so for this one, for our base pipeline that does not require any sort of scaling or anything, there's not really any value here, to be honest. Like this is really just a way to kind of cleanly handle your code. But on the flip side here, we have this pipeline. Now this one actually does see a benefit in doing the pipeline. What do I mean by that? So with the logistic regression support vector machine pipeline, we have to do a scaling of the data. And the reason that we have to do a scaling of the data is because these particular algorithms are sensitive to like the numerical values that you see within the range of each of the respective features. So what I mean by that is, let's say I have one feature that has a range between -1 million and +1 million, and then I have another feature that's got a range of integer values between -5 and +5. Well, trying to fit that model, or trying to fit the data to an algorithm like that, it's going to be more sensitive to that one feature I mentioned with the crazy range, like the million to a +1 million, -1 million. So how we handled that was, if we come back up here, where is it at? So you can see we actually did a standardization here. So I actually imported scikit-learn standard scaler here. And so recall, I did mention this in the last stream, that you can do one of two things. You can do a normalization or a standardization. The difference between the two is normalization, it scales all the values between 0 and 1, whereas standardization looks at the standard deviation of the values and then I think it just captures like how far, well, yeah, it captures the standard deviations away from the mean for that particular value. And so you might be wondering, well, when should I choose one versus the other? I would say you would want to choose normalization when you have like a standard range of values, if you will. What I mean by that is like you might have like 50 different records, but they all might fall within like the same sort of range here, and you don't have any crazy outliers. Outlier is the keyword here. So if you have crazy outliers, if you try to scale like let's say I had 50 numbers, and like the first 49 numbers were like just one, like a value of 1 through 5, and then the 50th number was a million. If I tried to do a normalization on that, then it's going to take those 49 and then like really squeeze it toward the 0, and it's going to take that million and really squeeze it toward the 1 side. So you can see then like, well, we're kind of losing information because we are taking like the outlier value is very much skewing our results, and it's taking the 49 other values and really squeezing it into one spot. Now, for this particular case, I probably could have gone with a normalization because there was not really crazy values here, especially like when you consider like between different features. Like there are different ranges here. So I opted for a standardization instead. And so, yeah, that's that. Oh my gosh, I did a lot of talking in like 10 minutes. I need to take a breath, literally. Hold on. Okay, so yeah, so we hardened all that into this feature engineering code here. Oh, that's what I wanted to note here is, so when we actually fit, the purpose of our pipeline here is that at the end of the day, we're going to be able to, and you can even see this right here with our test data set. We're loading in our test data set right here, and we are applying the transformations to that raw data set. When you apply those transformations, we want to apply the standardization in the same way that we do every time. So with that, there are two ways you can kind of approach this when you think about later inference. You could either save the standardizer, because we have to do a fit on the standardizer. And so in order to make sure that we are getting the same standardization every single time, we need to save out that standardization file as something like a pickle file. So we could do that, but what I'm not wild about with that is that, okay, now we have one pickle file for a standardizer, if you will, and then we have another pickle file that is going to eventually represent the final trained model. So we have two separate files there, and then even if we applied like we could apply other things, and I don't want hand gestures. But if we try to apply other things, you can imagine we don't want to have to necessarily manage all those files as separate pickle files. So the benefit of a pipeline, the scikit-learn pipeline, is that when we fit the raw data to the pipeline, it's going to fit the standard scaler and the model algorithm in one thing, so that way we can save it as one pickle file and reload and use it as one pickle file. So that's the benefit I like of pipeline, and I did not explain well last time. Okay, so now let's move into the focus for today's stream, and that is going to be model selection. Now, before we jump into this, I should actually say, and I think I kind of iterated it before, this is actually, you might be surprised, would comprise probably the least amount of time that a data scientist would do on a modeling effort. Most of the amount of time that a data scientist is going to spend on a modeling effort is going to be between exploratory data analysis and feature engineering. And actually, well, we didn't have to worry about it for this effort, but like there's actually a precursor step to this, and that is data gathering. And data gathering can be quite a hard step too. It's just that we did not have to necessarily worry about that here because Kaggle gave us the data on a silver platter and said, here's your data, here's everything that you're going to work with. So we didn't have to worry about that. But in the real world, the data gathering piece, that might be even the biggest piece. But for our effort, the standardization, the exploratory data analysis and the feature engineering is probably together comprises, 80 to 85% of our work. The model selection is actually not going to be too bad. So now you might be wondering, which algorithm should we select here? Now, the only thing, so we need to be mindful that this is a binary classification problem. At the end of the day, we are trying to predict one of two values. We are trying to predict, is this person an extrovert or is this person an introvert? So that's really our only constraint here. So you might be wondering, and this is going to be a trick question, what is the best algorithm to use for a binary classification problem? Think about it for a second. Again, I am saying this is a trick question. The answer is it's the algorithm that generalizes best to your data. And basically what I'm saying is like we can't necessarily, like, a lot of people are big fans of XGBoost, and we are going to be using XGBoost here. And spoiler alert, if you look at this notebook, that's the algorithm we end up choosing. But we just don't know necessarily unless we start testing out these various algorithms to see which one is going to generalize the best against our data. So we're actually going to select a number of them. So just to kind of keep things simple for our purposes, I landed on 5 here. So you can see here we've got random forest classifier, XGBoost, and decision tree. Now, the reason I'm calling I skipped past the other two, we'll come back to those, but these three, the random forest classifier, XGBoost, and decision tree. So decision tree obviously is a decision tree, and then random forest classifier and then XGBoost are kind of built on top of that with decision trees in different ways, with XGBoost applying gradient boosting, and then random forest being kind of like a more a scaled version of this decision tree. And so these kinds of decision tree models are not sensitive to things like multicollinearity nor scaling, which is why you can see we created 2 pipelines here. We have the standard pipeline, and then we have the pipeline LR. Again, LR stands for logistic regression, where we applied the extra engineering that we needed to with the standardization and the what else? I did something else too. What was the other thing? Or maybe not. Maybe it was just the standardization. Oh, we had if you recall, we had the multicollinearity issue between the stage sphere and the it was another binary feature, and so we took the naive approach of handling the multicollinearity problem by simply just dropping one of those features. Now, again, I talked about this in the previous stream with multicollinearity. I don't like this approach. I don't like the approach that I took here because we are throwing away information. But at the same time, it's like, well, what are you going to do? Like, we need to be mindful of multicollinearity. So I mentioned in that previous stream, if this was a real world problem, because these are like stage fear is a binary yes or no, I would actually go back and ask if we can get a more nuanced data on that. And what I meant by that is, instead of a binary yes or no, maybe we give a range of values instead of, so we might say a 0 to 10, 0 being like, I have no stage fear at all, or 10 being, I have a ton of stage fear. And then you can have values in the middle. And so that would help to solve the multicollinearity issue. But because this is a static data set that we have no business partner to be able to go at and ask that for, we're having to take this naive, and I'll say poor approach. So I will knock myself on that one. And again, I'm sure that the people on Kaggle who take these competitions very seriously probably had a different approach to this. I haven't gone out and looked to see what that is. I'm sure they had some interesting ideas out there. But yeah, we're taking a naive approach here. Okay, so when it comes to model selection, so how do we test to make sure which of the models or the algorithms are going to be the most valuable? Excuse me. The first thing that we're going to do here is we actually need to be mindful of hyperparameter tuning. What is hyperparameter tuning? So when you instantiate the model algorithm for the first time, it has the way I kind of imagine it is, imagine like a machine with a bunch of knobs and dials that if you turn up one knob, then it's going to affect the results compared to how you turn another knob, if you will. and then like but it doesn't change the underlying data at all per se. It's just saying we're going to be more sensitive to this part of the algorithm and less sensitive to this part of the other algorithm. So we call this hyperparameter tuning. And the other thing that we need to be mindful of here, and let me scroll back up to the top, is if you recall, we actually have a bit of that's not it. Where's the graph I'm looking for? Okay, yeah, here's what I want to look for. So this is our target feature within our training data set, and you can see we have a problem with a target class imbalance. And what I mean by that is, I explained this in the other stream. I'll go ahead and explain it again here. Let's take an extreme approach here. Let's say that our target class imbalance was that we had 99% extroverts and 1% introverts. The problem with trying to fit data in that scenario is that, yes, the model is going to get very, very good at trying to understand what an extrovert is, but it does not have enough information to necessarily generalize between, okay, what is an extrovert versus what is an introvert. And so there are multiple ways that you can kind of think around this. So one way you could do it is you could balance out the data. So you could say, you know what, I only 26% of my data is introverts. So I'm going to say, okay, for this extrovert thing, I'm just going to cut out a number of records to kind of try to balance that. I don't like that approach because you are essentially losing information, or you're throwing away records, and we don't have that many for this particular data set. I can't remember off the top of my head how many records are. I think there's something like 18,000. That sounds like a lot, but in practice, that's really not that much. Like, I've worked on real world efforts that span into tens of thousands, if not millions of records when it comes to training. So like I think it's 1,800, or maybe it is 18,000. I don't know. Either way, it's a relatively small data set, so I'm not inclined to want to throw away data. Another way that you could address this, and I'm going to talk about this one, but I'm going to talk about this one as something that I would actually never recommend in practice, and that is something called SMOTE. SMOTE is an acronym that stands for Synthetic Minority Oversampling Technique, I think, off the top of my head. And as the name implies there, synthetic, it's basically taking the undersampled class here and kind of doing like a creating new additional fake records that look very similar to the undersampled class. Now, why I don't like doing that is exactly what it sounds like. You are synthesizing data. You are making up fake data, and that is that would be extremely concerning in my book, especially if you're working in a real world context and you're like, I don't know, let's say I'm working for a company and I do a SMOTE on my thing, and like for some reason the company experiences a lawsuit, and I want to go in front of a judge and say, well, the reason that my model is performing this way is because I generated fake data. No, like, so I just bring that up as like, there may be cases where you want to do that, or it might be useful to do that, but generally speaking, I would say that's a really bad approach. So instead, what we're going to do is we are actually going to do something called a stratified k-fold. And I actually wrote a blog post on this a couple years ago, and I created this little graphic here to kind of help illustrate. But what is a k-fold cross-validation does, or a stratified k-fold does here, is you can imagine like, so what we do with our training data is we take our training data and then we will set out a holdout data set. We generally call this like our validation data set. To that way, so whenever we train our model, we are training just on the training data, and then we take our validation data set and then we analyze the results against that validation data set. And the reason that we do that is because the validation data set also does have labels associated to it, so we know the ground truth there. So you could see here, if we just did that without any sort of k-fold thing, then just imagine it was just like this top row. So then we are training on like just this one part of the data here, and then we are holding this part out, and then the model never sees that. So what k-fold cross-validation does is it basically says, okay, we're going to take your data and we're going to split it a number of times, or however many times you want to, and then we're going to evaluate it each time at each instance that we do like our fold thing. So you can see here, so if we split our data into 5 different times, we might do a train on this these folds 2 through 5, and then do a validation against fold 1 here. For the second pass, we might do a training on folds 1, 3, 4, and 5 here, and then do the validation on the number 2 here, etc., etc. And then once we have completed doing this validation across all these, then we might use our objective metric and see, okay, what is the mean, like what was the average between all of these, like what was the mean. And we'll if that's a little bit esoteric right now, don't worry, we'll get into the code here in a little bit, and hopefully it'll kind of start to make more sense. Is there anything else I want to cover before we jump into the code? No, I think we're gonna go ahead and jump into the code now. So I'm opening up this notebook. So this is the exact same notebook that we worked through last time. Nothing new here. This is picking up exactly right where we left off. So I'm going to say, in fact, I'm going to say this is a new section, model selection. And now, like I said, we are going to cover hyperparameter tuning. Okay, now, if you recall from the previous streams as well, I also wanted to demonstrate how to think about these things, knowing that, or like how to approach a project like this, knowing that we now have AI coding tools that are available to us. And for me personally, when it comes to thinking about like through a data science project, it's still extremely important for a human to understand everything that we basically talked about at a conceptual level. It's good to understand the principles of multi-collinearity, target class imbalance, feature engineering, scaling, and so that's what we've been focused on in this stream. The code's still important, but that is like, as long as we understand the concepts, then we could use an AI coding tool to help us through the syntax, because the syntax is really just taking our concepts that we understand in our head as plain English or plain language, and then transforming it into something that the computer can understand and make sense of. So to that end, we're actually going to be using a framework called Optuna. So I have actually in the past primarily used scikit-learn's grid search functionality. To be honest, I'm not really sure what the value of like Optuna is over grid search. I'm just aware that like this is like the more standard way that people do hyperparameter tuning these days. And again, basically what hyperparameter tuning is going to be is basically trying to figure out, okay, we're going to offer a number of different ranges and values for these. Like I said, imagine like a black box, a machine with all these knobs and dials that you can tune up and tune down, where we're going to do basically a huge combination of those to see, okay, at the end of the day, which one's performing the best. So I'm actually going to go ahead and, instead of typing out the code, I'm going to try to see if we can do, because I actually originally did do this with an AI coding assistant. I did have to do a little bit of cleanup, but let's see if I can basically replicate what I did here on the fly. Okay, so I'm going to say I'm interested in doing a doing a hyperparameter tuning for my binary classification problem. I would like to test out XGBoost and apply a stratified k-fold when doing the hyperparameter tuning. I would like to use ROC-AUC as the target metric. My data is saved in a variable called X. What else? Please feel free to suggest parameter values to assess. Also, please use Optuna as the framework for this work. Okay, so let's see how well it does. All right, so we'll give it just a second to see how well it generates. And it looks like Okay, it did everything almost correctly, except I just realized that I actually have my data saved off as. Um, do I have it saved off as? I don't know. Well, it didn't do it quite perfectly. Like this is actually pretty darn close though. So I'm gonna go ahead and accept these results. So the one piece that I did not necessarily get correct here is that I actually have a Y train. In fact, I'm gonna say this. I'm just gonna highlight this. Can you update this to use df train, or I'm sorry, X train and Y train. Okay. Hopefully it'll do this. If not, I might have to manually like type some of this stuff out again. All right. I think it accept. All right. So X, hold on. Let me just look at my notes here because I still think this is kind of incorrect. And I think this might actually be my fault because I don't think I actually saved it in this notebook as X train and Y train. In fact, let me go ahead and check. X train. No, I did not. Okay, that would be why I can't find it because I didn't do this. All right. So what did I do here? Wait, I saved it as the raw. Oh, okay. I see what I did. Okay. So what I'm actually going to do here, this is just another little bit of code. So it's basically saying I want to take my X, I want to take my Y, convert them to pandas, do a train test split on them. Yeah, so I actually did the train test split outside here, and then I passed these just passed in the, well, what did I do here? Might help if I read, my notes are not super clean on this right now. Okay, I think, you know what, just for time's sake, I'm just going to copy and paste this one. But like the GitHub Copilot was actually pretty darn close on here. It's just that like I actually did all this work like 3 weeks ago and I kind of forgot like how I did it. So basically how this works here is that we define a function that we are going to use for our opt-unit trials. Now, what I want to highlight here is that these parameters, so these are actually going to be the parameters that we test against. And so you could see here that we've got, like these are expected parameters for XGBoost specifically. And you can see here, like this is where it's actually producing the parameter values for like the range of values for like number of estimators or maximum depth, etc. Now you might be wondering now, because this is a question I've always had and I don't really have a solid answer, and I tried to use ChatGPT to get an answer and it didn't really give a good answer, is how do I know what ranges to set? Like how do I know for a number of estimators that I should set a range of values to test between 100 and 500, or for here for max depth, how do I know to set it between 3 and 10? I don't have a clean answer for that, so I'm just going to be straight up with that, and neither did ChatGPT. So you can see here that GitHub Copilot did generate these suggested values for us. Now, what I want to call out here, let's just continue walking down through this function. So we talked about the stratified k-fold here, so we are going to do 5 splits, very similar to, let's come back to this picture. So you can see here we're doing 5 splits. We could do more. We're just going to keep it kind of simple with 5. And then as each iteration goes on, so recall that we want to do an ROC AUC as our target metric. So I'm not do I want to talk about that today, what that is? It's basically a standard metric that people use for assessing like binary classification problems. That is the laziest explanation I can give to you. Like there's better explanations out there for that. But as you can see here, so for each of the splits that we were doing within the stratified k-fold, we are going to fit we're first going to do a split of the data between like an X train versus an X validation, and then we are actually going to fit the data to the model as if we are training the model. Well, actually, first we're instantiating it and passing in all these parameters above, fitting the data, predicting like the validation data set against the model that we just trained, and then you can see, because we're producing the ROC AUC score here, we're appending it to this, and then finally we're going to return the mean of the values here. So that is just for XGBoost. So now I'm going to say here, I can come down here and say, I want to do a hyperparameter tuning very similar to how we did for XGBoost above. Please be I would like to do this for a random forest classifier, a decision tree algorithm, a support vector machine, SVM for short, and a logistic regression model. Please be aware for the latter two algorithms, SVM and logistic regression, that we will be making use of X-train LR and Y train LR instead of X-train slash Y train. And again, we explained this above. Underscore LR stands for logistic regression, and that just is reflective of the fact that we had to do some additional transformations for these specific algorithms, not tums. All right, so let's go ahead and see it produce all this code here. So, and the nice thing about doing it this way is, because once you get one of these settled, you can see that like all these other ones here are going to be kind of like similar. So it's basically kind of trying to follow a pattern here of, okay, I did this thing above, now let's do like this other kind of thing below. Okay, so you can see here, it generated all the functions that we need to do here. So I'm going to go ahead and hit accept. Now, this is just defining the functions. Like, we're not actually running the hyperparameter tuning when we run this cell. It's just preparing ourselves for this. So let me scroll down and review my notes here first really quick. Now, I'm going to say, okay, so I actually am going to because I did a lot of customization here. I'm going to try to do it with GitHub Copilot and then kind of show you the adjustments that I had to make. So I'm going to say, please use so this is the one, I actually can't do it in this cell. This is the one downside of working in how I work with GitHub Copilot is it seems like when you're working within a Jupyter Notebook specifically, that when I go in here and, like let's say I'm in this cell right here and I ask, please make, let me go ahead and type out the full prompt. I'm going to say, please, I want to do a hyperparameter tuning on my data set using all the functions above. Please help me set up the code to do this. I don't know that this is going to work because in my experience, it is, actually it looks like it's doing all right. Maybe, hold on, let me look at my notes here. Yeah, no, actually that did it kind of all right. Okay, well, never mind. Well, my comment was basically going to be like, in my experience, like if you don't have all your code in a single cell, then I've historically had the problem of like it kind of doesn't recognize that this other code exists. So I've always had to like kind of do things in the same cell, and then if I wanted to split it off into a different cell later, I'd have to copy and paste. But actually, this looked like it worked. So let's go ahead and. Now this might take a while, so I'm actually going to go ahead and run this and see how long it takes. But while it is running, I don't know why it didn't. Oh, for some reason, if you can see off here on the right, when I do code like this, VS Code is trying to detect the kind of code that I'm writing, and you'll see here it's trying to detect this as Julia, and I don't really understand why it does this. Largely because like it should be aware of the fact that we're already we're not using Julia. We're clearly been using Python throughout this entire time. So let me go ahead and what happened here? I'm gonna go ahead and just delete this cell. But I'm afraid that I didn't necessarily set this up correctly. Hold on. Let me make sure that I am actually doing this or importing my data correctly. Okay, let me try this again. X, Y. Did I not save a Y? Did I not save a Y here? I might have not saved a Y. Okay, let me load in some other data here. Okay, sorry, I'm getting kind of lazy, but we'll talk about what I'm doing here in a second. Okay, so basically I just added the cell here. Basically what we're doing here is we're reloading our data. We're doing a simple personality encoding, and then basically setting up the X and Y here for our hyperparameter tuning. So now all this code should work. So let's go ahead and restart and run all. And let's see how this goes. I want to make sure that this code is working before I actually go and talk about something else. Okay, it appears to be working. So while this is plugging and chugging, because remember, it's doing like all these different combinations of the various things that it can do. This actually does take a while. This is not the precise code that I wrote for my for the actual notebook though, and I want to show you why this is not exactly the right the exact code that I wrote in my official notebook, if you will. Let me scroll down and find it. Where is it at? We're getting close. Where is it? Okay, so here's all of our trials. Okay, so here is the code. Basically, what I had happened to me was that I was having a bit of an issue where sometimes there would be like a timeout or whatever, and the problem, the challenge with that is if I've already done the hyperparameter tuning on the XGBoost and the random forest classifier, and there's like a failure out with the decision tree, I don't want to have to go and rerun all of that. And so kind of the kludgy way that I got around that is, as you can see, is after each of these trials is done, I was in this official notebook actually saving off these parameters as JSON files, so that way if for whatever reason this code block failed, then I could simply just no, yes, we've already done these two, skip this, continue on. So, and this is going to take a while. I'm not even sure that I'm necessarily going to let this run the entire time. And it looks like we had a bit of a failure there anyway. What happened there? Why is that oh, yeah, these are all indented weird. That's why. Okay, so you can see here we ran into the exact issue that I was trying to avoid, and that is the XGBoost ran just fine, but then after that, because I had that weird indentation there, we have to rerun this block here, and because I did not save it off, because I did not save it off, now we are stuck having to rerun everything, and this again is a little bit timely. So I am going to let this run for a minute just to see how long it takes. And so I can literally take a breather, because I feel like I've been talking like a million words a minute, and I'm out of breath. That Rooster Booster is good. I'm so glad Bloomington got a QT. All right. How many trials did I actually have? I had set to 30. Oh, golly. Well, that's partially why. Yeah, so you can see here, this is still doing the study with the XGBoost, and I think this is going to take like a solid 5 minutes. And again, I'm not, well, while that's continuing to run, let me just go ahead and show the results in the final notebook here. Oh, yeah, that's right. So you can see here within the final notebook that we actually don't have the results here. And the reason for that is because this can take so long. I actually like to set these Boolean values that kind of represent toggles in my notebook. And the reason I do that is because we're going to upload, we're going to demonstrate how I upload this to Kaggle. And so when I upload it to Kaggle and I run the whole notebook, if I have this toggle turned on, which is not this is not necessary. It's not necessary to do this for model training. This is to prepare us for model training. And so when I'm on Kaggle, I don't need to do this again. I've already done this once. I've already got my parameters saved, and therefore, what's the purpose in doing this again? And that's not why it's not toggled on here. And I actually do set all my toggles at the top of my notebook. So like you can see here, let me show where. Yeah, so you can see here that I got a couple of different things where like I basically have these turned off for when I'm doing an official thing, just for runtime efficiency. Okay, all right, let me come back down. Yeah, coming back down. want to find my place in the notebook because we're actually, believe it or not, we are getting very, very close to the end of this stream, or at least, well, not to the end of the stream, but at least to the end of model selection. Again, like I was saying, in a real world setting, exploratory data analysis and feature engineering, and then also we didn't have to worry about this, but data gathering, those are going to take the bulk up of your time. Like the model, this final stuff that we're doing here, not too bad, and does not take nearly the time that the other elements needed. Yeah, this is going to take forever. Yeah. Well, actually, you know what? I mean, it's already on decision tree. Do I want to let it keep running? I think I'm going to let it keep running. Just cause. Why not? Well, is it... Here, can I show it as a scrollable element? Well, what I want to highlight here, though, is so like you can see here for the decision tree that at the end of running all these different things. So let's just look at the logs here. So for each of the trials, it's trying out. Okay, let's try a max depth of 8 or a max depth of 15 or a min sample split of 10, and it's basically just trying all these different combinations. And then you can see it finishes out because we are using that ROC AUC value, and it'll give us a numerical value here for each of our trials. And so at the end of this, you can see that it says, okay, the decision tree, the best parameters that we had were these parameters here. So we landed on 12, and that the best decision tree with these parameters has an AUC of 0.97025. I'm intentionally calling out 0.97025 because I'm going to show the Kaggle leaderboard in a minute, and you'll see that basically the top 100 are all 0.97, and it's really like the trailing values of the, what is this, tenths, hundreds, thousands, 10,000s, the thousands and the 10,000s literally are going to make a difference within this competition. Yeah. All right. By the way, I am taking questions on YouTube or LinkedIn, so if you have any questions while this is continuing to run, feel free to ask, and I'll be happy to address them. I don't know why this one's taking so long. The support vector machine. It is taking a while. Yeah. And again, I'm not sure how much I want to let this run. I'm going to look at my notes here to see what else I had done. Okay, so I'm going to show this next part. I'm actually not going to execute this in reality. Basically, what I did was, okay, after I determined the best parameters for all these different ones, recall that we did the stratified k-fold as part of this. Now, so with with the stratified k-fold, with each of the folds, we are essentially throwing away information because we are doing a training just on part of the data set. And yeah, never mind. Because, well, basically what I was doing here is I was taking the parameters for each of the best models and then doing another final test. And of course, I don't have the final information here. But basically, at the end of the day, it was XGBoost that like edged out the others, but not by much. Like you can see here, like as our trials are finishing, so like the AUC for the decision tree was 0.97025. Scroll up some more. Oh wait, that is the... Okay, here's random forest. So this is 0.97290. So again, 0.97. They're both 0.97, but you can see that the random forest classifier still does actually beat it out by just a hair. And then you can see with XGBoost, it again 0.97333. XGBoost is actually faring the best. And so that is actually the final algorithm that I ended up landing on. And so you can see here that we have the best parameters. So what I actually did was, after I landed on my final like this is the algorithm that I want to use, and these are the parameters that I want to use. In fact, I'm just going to interrupt this because this is just taking way too long. Oh wow, it's already been 6 minutes. I've been trying to kill too much time here. In fact, I'm just going to comment out all this code, so that way I don't accidentally run it again. Okay, so I'm actually gonna copy and paste in like the best parameters that I ended up using. So I'm gonna say here are my setting the final parameters. So these are the parameters that I ended up generating from my Optuna study a couple weeks ago when I was doing this. Now I want to basically setting ourselves up for the final submission. So what we need to do for that is I'm going to first load in the data. load in the data. So we're loading on our data here. So we're loading the train data, raw data. Again, if you're wondering what this is, we're going to get around to this. Just don't worry about that for too much right now. Just know that this block is loading in our training and testing data. We statically set our parameters. Now I could have saved this as a JSON file or something and loaded in the JSON file, but I'm just hard coding the values here because these values are important for training, but we don't need to save these off for well, they're saved as part of the pipeline pickle file that we'll be saving out representing our final model, but we don't necessarily need to memorize those, if you will. Now, if you recall, we're going to just set up our X train and Y train. So this is going to be very similar to what we did already before. And then we are actually going to set up our final pipeline. And so we're going to say final pipeline. Now, this is actually, now I want to call out something here. This is kind of the first time we've actually put our hands on the keyboard so far in this stream. Most of the interaction that we're doing here is with an AI coding assistant. Again, with the firm understanding of the concepts around it, and then also we did do, well, I did, well, no, we did do, we stepped through the code. And the reason I call that out is I actually posted this to LinkedIn earlier today. I'm going to pull this up again just so you can all see. There was an article that came out about the platform called Replit. So Replit's like a low code generative AI platform. And so you can see here per this article that whatever happened with this user here is they were using Replit to support their company database, and their generative AI kind of stuff deleted the whole database and then created a bunch of fake data. In the highlight of my post here, as I call out, is generative AI, when used appropriately, is a very powerful force for good. But when used inappropriately, is a very powerful force for bad. And so in the context of this stream, what I want to highlight here is I would always suggest, even when you are using an AI coding assistant, review the code. Understand what the code is doing. Because if you don't, then you find yourself in this situation, and this is a bad situation. That oh my gosh, I feel bad for those poor folks. That sucks. That happened to them. But you can have we always talk about generative AI in terms of the powerfulness of it, but we talk about it in a positive, powerful light, but we don't talk about the negative power. And what I mean negative power is exactly what I was talking about here is for a human individual to go and make that kind of bungle would actually require some effort. You'd actually have to go and kind of intentionally go out of your way to, make that kind of mistake. But with generative AI, oh yeah, it can make a major mistake in the snap of a finger. So, okay. Where was I getting at with that? So, okay, so coming back to here, so I'm going to say final pipeline equals pipeline, feature engineering. Now, if you recall from our pipeline here above, where is this pipeline? We only had one step here, but we're actually going to add an additional step here to represent our final pipeline. And you can see GitHub Copilot is trying to do this for us. So we have a two-step pipeline now. And then so this is going to be, so we basically ingest the raw data, and then we do our feature engineering on that raw data, and then we hand it off to the model as a single unit. And then as this single unit, we are able to save this out as a single pickle file, and then read it back in and make use of it for inference later down the line. Now, in a Kaggle computation, saving the pickle file out as a separate file is not really particularly necessary, because we aren't the only inference that we're going to do is on our test data set, and we can do that within our local Jupyter notebook here. And so we don't necessarily where this would be important is if in a real world context, if I was trying to build an API around this, I would take that pickle file, stick it in something like a Docker container, upload it to something like AWS SageMaker or whatever, and then that way I can make constant inferences with that on a regular basis. And again, we're not going to demonstrate that in this stream. That is way outside of the stream, but I've done streams on that before. Okay, so that is the final pipeline. So then, simply put, we just need to fit the training data to that final pipeline. So final pipeline.fit. So you can see here that we are doing .fit xtrain raw, and then y, I don't know why I didn't call this Y train raw. Train raw. Just to keep our naming kind of consistent. Because at this point we are now, because we're ready to produce the final results. We are going to train on the entire data set. Again, with our hyperparameter tuning, we did this k-fold thing. We are missing, like when we do this kind of training, that we are missing the like kind of information as we do the fold. But now that we've settled on the hyperparameter tuning and settled on the algorithm that we want to use, now we can make use of the entire data. So then we fit, and then we need to do, for Kaggle's purposes, we have our test data set, which we did load in here as xtest raw here. And so then we actually just need to produce the predictions and then save them in such a way that Kaggle kind of expects. So we're going to say y test pred equals final pipeline.predict xtest raw. And then we need to set up our actual submission. So the way that we do that here, so let's actually go and like recall what we need to do here. So I'm going to open a new tab from Kaggle. Oops, that's not what I wanted. Where is this? Where is the competition itself? Okay, so here's the competition itself. Now, as you can see here, per the competition entry, that it is expecting the final submission file to be in this format here, where you have essentially a CSV file that has the two features here of ID and personality. So like recall that like when we actually loaded in the raw data. In fact, let me go ahead and show that here. I'm going to take this, and that way I can show it. Xtest raw. Okay, so you can see here we have the features that we're going to be predicting against. Naturally, there's no target variable here because they intentionally did not supply the target for the test set, but we do need to carry over the ID here. So the way that we're going to do that here is simply saying final submission equals pl.dataframe. And then we're going to say ID. So the ID is going to be pl.read CSV. I'm actually loading well, why am I doing it that way? That's kind of, okay, I kind of did it a weird way, but it's all right. So we read this in dot select ID to series, ID dot to series. So this is basically just reloading the raw data set and grabbing the ID values here, and then doing a and getting a personality. So personality, and that's going to be pl dot series series y test spread. And if you recall, so whenever the predictions come out of the raw pipeline, they're coming out the numerical value of 0 is introvert and 1 is extrovert. So we need to convert that back into like the raw string values that Kaggle would expect. And then at the end of this, so after we do that, then we say final submit. Yeah, it was starting to do that for me anyway. So final submission.write CSV, and then once it in this specific file name, it actually notes it somewhere here, in here that once it's saved as this file name. So let's go ahead and run this. Like and this effectively wraps up our code, at least for we do need to do a little bit of stuff for Kaggle, but we'll talk about here in a minute. I'm gonna go ahead and do a restart and a run all. This shouldn't take too terribly long. Especially because I commented out the compute heavy, like, oh yeah, it's already done. Yeah, it's already done. Okay, so let's go ahead and look at our final submission, just to show you. So this is what our final submission looks like. These are all of our the IDs and the predicted values. This is exactly what we generated per the model that we trained. So that's it. That's the end of the project. So now let's go into Kaggle and see, okay, how do we actually submit our prediction here? So you can see I'm already logged in and authenticated as a user. Naturally, you're going to have to do that if you want to participate in this competition. Formally speaking, you can see the submit button. you can do just like a straight upload of the file here, or you can do like what I prefer to do, and that is the notebook kind of path. So I'm actually going to, so I already do have a notebook up in here, and you can see here that whenever I already did my run here, that I got a public score on the public data set of this value right here. So I'm actually going to go ahead and I'm going to revisit this notebook because this is the official notebook. But let's say I was starting from scratch here. I would actually go into this code section. I would go into a new notebook here. And so this is the interface that you get whenever you have a new notebook. Now, what I want to call out here is you'll notice off here on the right is that we have this this menu over here of like inputs and outputs that or additional configuration options that we can do for here. And additionally here, you can see that we can actually import a notebook from GitHub. So you can see for my notebook, I'm going to say DK. Well, I don't want to upload it to the GitHub. I want to import it from GitHub. So I'm going to say import notebook, browse files. No, I want to do it from GitHub. My apologies. I want to do it here. So I'm going to do Kaggle. Well, it's going to be DK Hundley / Kaggle Playgrounds competition, and then it's going to be on the main branch, and then I'm going to look for this is the exact notebook that we've been working on, this one right here. This is the official notebook, that is. So when I import it, because this is just pulling it in from GitHub, failed to fetch file content. I don't know why it's doing that. That's not a big deal anyway, because I kind of didn't want to cover that right now. But what I wanted to call out here is, so far in my notebook, we've been working locally, and we're finally going to come back around to like this weird thing that I've been showing. The weird thing being the load of the file. Well, where is it? Where is it? Well, I know it's at the very bottom cell here. It's basically this thing here, so I like to set up my code to where it will simply just run whether I am working in my local environment or I'm working in Kaggle. And so I do a kind of a cheater way around this, and the cheater way is I'm actually just going to delete out this starter code for now. Is making use of environment variables. So I'm going to say import OS, and I'm going to say list os.environ, and then it should produce it like, when you work on Kaggle for the first time, it's doing like a cloud notebook kind of thing. I think it's powered by Google Cloud Platform on the back end, because recall that Kaggle is actually a Google-owned company. So when the first time you set up a notebook or you start up a notebook on Kaggle, it actually takes a minute or so. But you can see here when I import OS and then I list out the environment variables here, you can see here that Kaggle actually does have a number of default environment variables. And so these are environment variables that I'm not necessarily going to have on my particular local machine. So what I did was I just grabbed one that sounded like Kaggle. So this one here, that basically says, okay, if we are up, that's what this code here is saying is, okay, if we are running up in Kaggle or not running up in Kaggle, then just load the data locally. And if we're not, or if we are on Kaggle, then load it as such. Now, you'll notice here, though, so how do we actually make reference of that data that we want to work with? Excuse me, the competition data, that is. So that is what this right bar here is for. We're going to go over here and we're going to do like an import. And so you can see here we get narrow down on like the competition data sets, for example. Or how do I do mine? I thought there was a way, like, this is not the typical way that I do it. I'm going to do introvert, overt. Yeah, okay, so this is it right here. So I'm just going to click this plus button here. And so what this is basically doing is it basically just mounted up the data that is for this competition up to this notebook. And so when I close out of here, now you can see under here that we have this competition data. And you might be wondering, well, how do I actually reference the file path appropriately? Well, you can see here there's like a little thing that you can just mouse over that says click to file path. And then you can see then I can just paste it in here. And that's the file path for the data that we want to load, which is exactly like we are seeing here. So that is one thing you need to be mindful of, is when you're working locally, your file path file pathing is probably not going to be the same as like what Kaggle would expect. And so this is my hacky solution around it. All right, so that's item number one to be considerate of. But then item number two to be considerate of is you'll notice that I did an import of OS here without an issue. But like, let's say I want to say import Optuna. And it may do this, like it may prove me wrong right here. Basically what I'm trying to get at is by default, the Kaggle notebooks are naturally not installed with every single third-party library that exists out there. So we're going to have to do at times a pip install on this notebook, so that way we can actually make use of some of these libraries. I don't know why it's taking so long here to do this import, but hopefully it'll wrap up here in a second. Yeah, and then I'll show you how I personally do the pip installs on Kaggle, because there's the what I call the messy but simple way, and then there's the more complex but clean way. Why is this taking so gosh darn long? All right, oh, it actually did it. Okay, and of course it did have this one, but let me try to import. What's another random library that may not be on here? Boto 3. Boto 3 is an AWS library. I'm going to guess Boto 3 is not in here. Okay, it is. All right, there's certainly one out there. So I was working with one called docx the other day for Word documents. Yeah, okay, there you go. So if I want, like, you could see here that we need to be mindful of ensuring that we're installing all our dependencies. And so the way that we actually do that, or the way that I do that, what you could do is you could, again, there's a naive way of doing this, and that is, so typically speaking, when you're working within a Jupyter notebook, it runs things as a Python code, but if you want to run it something as a typical shell command, what you do is you first start things off with an exclamation point, and then you would do like a pip install python-docx, for example, and then when I run that, it will do the install. Now, so that's the simple way, but the reason I don't like this way is because it's kind of messy here, because it produced all of these logs right here. So you can imagine if I've got like 10 of these things I need to install, now every time I run my Kaggle notebook, now I've got this whole long mess of logs just for my pip installs that it's just not aesthetically pleasing. There's a better way to do it. So let's talk about that better way. So what the first thing that I want to do is I need to do a couple of imports. So I'm going to say import OS, import sys, and import from subprocess, import check call, and called process error. Now these are standard Python things. Like, these are not third-party libraries that I am importing by any means. So you could reasonably expect to find that like you wouldn't have to do a pip install for any of these things. So the next thing is I actually want to set a list of my Python dependencies. So from our notebook here, I've actually been using UV locally. So the nice thing about UV is that it manages all of your virtual environment dependencies in a PyProject TOML file. So if I come into my PyProject TOML file, I could say, okay, here's all the dependencies I need. So I'm just going to copy all these, and I'm going to go over in here, and I'm going to say Python dependencies equals, looks like I kind of duplicated things there a little bit. So I've set all my dependencies that I need, and then I am going to, I'm actually just going to copy and paste this because I'm getting a little bit lazy. But like, I basically set a function here. This is what you can see that this is called the install quiet function, and it's basically doing the exact same thing that we were doing before, where we're just doing the pip install, but you can actually set flags like these Q flags that would not produce all of the logs that we saw associated to the thing, to the install. So when I run this, then as such, Python depend, yes it is. Oh, might help if I spelled that right. Okay. There we go. All right, so now that should go ahead and install everything for us, but you can see that, yeah, that it should do this quietly, where it's quietly in the sense that it's not producing all those verbose logs that we were seeing before. And again, sometimes Kaggle, because these are cloud notebooks, essentially can be a little bit finicky in the sense that like you can see that, I don't know why sometimes it takes it a minute to load, or like reload or whatever. Now you can kind of get a sense that it is working though from this metering up here. I don't know if you saw the CPU shoot up there for a second, or well, now, okay, now it's shooting up again. And then you like, if I was doing some heavy RAM stuff, like there's no, for this particular thing, we're not doing any heavy RAM stuff, but this helps to kind of give this little bar up here kind of helps to give an indicator of that the notebook is doing its thing. It's just kind of hard to tell from this, and it normally doesn't take this long, or I don't think it normally takes this long. Yeah, but we are getting very, very close to the end of the stream, and I'm actually going to pop into my final notebook just to kind of demonstrate the final, like how you do the final thing. Because I actually don't know if I can have two different notebooks that do a submission on my behalf to the same competition. Maybe you can, but I don't want to have to worry about that. I already have another notebook for that. This is annoying because I can't, like, I don't think it should take this long. So something tells me something's excuse me, something has stalled with this here. Well, I can't believe we've gone over an hour. I thought that we were going to wrap this up right under 1 hour, but I guess not. But we are getting super close to done. Maybe like 5-10 minutes we'll be out of here. In fact, I'm going to go ahead and cancel this run and try it again. All right. Restart and clear the notebook. All right, now let's see if I can run this again. Maybe this time it'll actually not stall on me, or maybe it could have been that it was working, but again, because I'm doing this quiet thing, the quiet thing, then like I'm not able to see the logs as it's doing its thing. But while it's doing that thing, I'm actually going to pop into the, I'm actually not too worried about this. Like, I know this code works for sure. So I'm going to pop into the final notebook, my final notebook. Where is my final notebook? Where's my final notebook? Your work. All right. So this is the notebook that we just started. By the way, every time you start up a new notebook, it just gives it this like unique identifier name. You can change that, of course. Like let me come back in here. It's as simple as just clicking up here and saying my new notebook or something like that, and just hitting enter, and now you have a new name. And by the way, the other thing I should mention is if you want to share your work with others, by default, these notebooks are private, and it's just as simple as going up to the share button here and just making it public. So just be aware of that if you want to be able to share your work. Okay, so I'm going to come back into this other notebook here. Now, so just to kind of run through everything that we did. Well, I'm not going to run through everything that we did holistically, but kind of just for like the Kaggle stuff. So we're doing our pip installs up here at the top. We are loading our data per the absence or presence of the Kaggle run type environment variable. Again, this is really hacky. Like the way I did it over here was super hacky. And then you can see as we continue to scroll, you can see that we finally will produce our final submission file here. So I'm actually so this is like the view interface. I'm going to go into the edit interface. And I'm going to go ahead and say, okay, I want to submit, like, let's say I went ahead and ran all this. I want to submit this to the competition. So you can only do up to 5 submissions a day. I'm going to go ahead and hit this submit button. And what's going to happen here is when I hit this submit button with the version 3 is it's actually going to run all of this code in the background, and it will produce a new final score and a new place on the leaderboard for me. Okay, and it's going to take a few minutes, so we'll give it a few minutes, and I'm going to sip up my drink here while we're waiting. Okay. I'm really looking forward to this being done. It was a fun project. It's just that, like, sometimes these things, I just want to get on to like working on different things. I haven't totally settled on what I want the next stream to be. I'm kind of tempted to do a stream on comparing the various different AI coding tools. So like comparing the experience of using GitHub Copilot with VS Code to like Cursor or Windsurf or Claude Code. I'm kind of tempted to do that because I got my hands dirty with the Claude Code, or with Claude Code specifically, for the first time like 2 weeks ago. And to be honest, I didn't like it. And the reason I didn't like it is because so it is a CLI based tool, and basically it is very agentic in the sense that it is like it makes sense of all the files that you're working with, and then kind of writes code for you. But what I don't like about it is because you're entirely working in a command line interface, you don't actually necessarily see the code. You could open up the code for sure on the side and then go and look at it, but it just, I guess the way that I would phrase it is Claude Code seems to not encourage you to review your own code. It kind of almost encourages you to just kind of trust it. And there's a goodness and a badness to that. The goodness is like, yeah, it does do a good job for the most part, but the badness is hallucinations. And then we have this issue like I was referring to here, where with this article, these poor folks with this company here probably had a not fun day. Those poor folks. All right, so you could see this is still running in the background, so we can actually look at the logs here. So you can see it's the greatest amount of time that it takes here is actually just for starting up the instance behind the scene. Oh, it looks like it already finished. Okay, or did it finish? All right, so yeah, this is it looks like my best score was not this was from version 2. I don't know why the scores would be any different at all, because like I that was the other thing I should have noted here is with my hyperparameter tuning, I actually did set the random state on them, so like that way we could get reproducible results every single time. But I want to, where can I actually view that at? I want to view, I wanted to view like the actual, what am I calling it? My score for this third run. I don't know how to do that on here. Do I go into the edit? Maybe it's an edit interface, and maybe it's, oh, well, yeah, no, you can see here. Yeah, I was right. Like, I don't know why it acted like this one was better, because you could see there, I mean, sure, there could be trailing values after these that maybe this one was better. No, they should be the exact same, whatever. But you could see one thing I do want to call out, you can only submit, you can only do a submission up to 5 times a day. Now let's close things out by just reviewing the final Kaggle leaderboard, just to kind of show you what that looks like. So I'm going to go over and back into the competition, and then I'm going to go over to the leaderboard. Now, if you recall from the first stream, the way that these competitions work is that Kaggle gives you a test data set that you test against, and that puts you for a position on the public leaderboard. However, I believe that test data set is only like maybe a subset of the true final private data set. The data set, so basically they have a different data set that is private until the end of the competition, and at which point people will be able to be judged against that. And then so like this is just the public leaderboard. There can definitely be shakeups with the final private leaderboard, given that, oh, it actually does say here, the leaderboard is calculated with approximately 20% of the test data. The final results will be based on the other 80%, so the final standings may be different. And so let's jump to my place in the leaderboard, so you can see that I am place number 1364. But let's look at the scores over here. Like everybody, this is exactly what I was talking about. Like everybody is like getting like these sorts of scores, and if like so I'm probably like 1/3 of the way through the pack, or like 33% of the way through the pack. But even like the top score here is still 0.97. Like mine was 0.97398, but like, again, this competition is going to come down to the 10,000, the thousandths or the 10,000ths place, decimal place there. Yeah. Oh yeah, this is exactly what I was talking about. I'm not submitting 104 entries. I don't have that kind of time, guys. Yeah. So with that, we are officially done with this stream. Yay. So I hope you really appreciated this stream. I always appreciate getting back into doing things like this. It helps me to refresh my skills. It helps me to, like, this is actually the first time I've done some of these Kaggle competitions in the past. This is the first time when I actually lean more on the AI coding assistant to help me out with this than anything. I actually think I spent more time streaming about this than I actually did the project. I think I did a collective maybe 2.5 hours on of actual work to do everything that you saw with my notebook, and I think we ended up streaming for like a collective 3.5 hours. So that's the power of using AI coding assistants if you are using them in a correct way. All right, with that, we are going to wrap up things here right now. I hope you all have a good weekend, and I will see you in the next one.